Good evening, class 11 students. Today I am here to explain, to discuss about the dimensions of the physical quantities. What is dimension? It is nothing but the symbol used to represent the fundamental quantities. What are the fundamental quantities? As we have already discussed: mass, length, time, luminous intensity, temperature, current, and mole. The symbol represented to this fundamental quantity is called dimension. The dimension of mass is capital M, the dimension of length is capital L, the dimension of time is capital T, the dimension of temperature is K or theta, you can write any one, the dimensions of current is A, and the dimensions of luminous intensity is CD, that is candela, and the dimensions of moles per mole is nothing but mole. So these are the fundamental quantities and their dimensions. So what do you mean by the next one is any physical quantity we can represent in terms of fundamental quantities, dimensions. Suppose if I say that the dimensional formula of a physical quantity is ml raised to t raised to minus 2. ml t raised to minus 2. It means that m for mass, L for length, t raised to minus 2 is second to the power of minus 2. That is time. You know that. So this is the quantity called force. So how can you write? If you want to write any quantity's dimensional formula, first you should know the physical quantities formula and its definition, anyone. So for example, force. What is force? Mass into acceleration. This mass into acceleration, how do you solve the dimensional formula? See here, force is equal to mass into acceleration. Force is equal to mass into acceleration. Mass into acceleration. So the dimensional formula is always represented in square brackets, students. Don't forget. So F we have kept in square bracket means this is the dimensional formula for force. Is given by dimensional formula of mass m and dimensional formula for acceleration. What is acceleration? Velocity upon time. What is velocity? Distance upon time. Already time is there. Distance by time square. So the dimensional formula for force is given by mass, that is m, L, t raised to minus 2. In this way we derive the dimensional formula for force. Similarly, the dimensional formula for pressure also I am showing you. Please see that here. The dimensional formula for pressure. Pressure means force upon area. Area means distance whole square, L square. Force you know that here. Then we will get the formula ml raised to minus 1 t raised to minus 2. And the next one is here energy. One more example. Energy. Energy dimensional formula. Energy is equal to work done. Work done is equal to force into displacement. Then again you put the dimensional formula. Then you will get ml square t raised to minus 2 here. And the last one is universal gravitational constant. You know the formula for universal gravitational constant you have studied in your 9th class. What is it? F r square upon m1 m2. Accordingly you substitute the dimensions of all the quantities, you will get the answer m raised to minus 1, L raised to 3, t raised to minus 3 you will get here. Okay children. Similarly angle. How can you find the dimensional formula for angle? Angle is equal to arc upon radius. Arc means again distance, that is length L, and radius means L. L by L cancels. So there is no dimension for angle. So in this way, please go through NCERT. At the end of the NCERT book, there are many physical quantities given, their formulae and then dimension formulae. Please do practice and you will get very much confidence to use this dimension formulae wherever it is necessary here. And the next one is, you know, there are 4 types of dimensional quantities. What are they? Number 1, dimensional variables. What are the dimensional variables? The variables whose dimensional formula changes. Example, just now we have done force, pressure, work and so on here. Second quantity is dimensional constants. Those constants which has dimensions, but they are constants. They are not variables. Example, just now we have done gravitational constant, universal gravitational constant, capital G, and one more example you can do H, Planck's constant. And the third one is dimensionless variables. The values will vary but they don't have dimensions. Example, strain. Strain means change in the length upon original length. So, but length and length is having same dimensions. Madam, it has got no dimension. No, it has got no dimension. It is very clear, but the value changes according to the direction. Strain. You will study in your forthcoming chapters about this strain. Okay, and the fourth one is dimensionless constant. I think very easy it is. There is constant, but it doesn't have any dimension. Example, 2 pi and log values, all trigonometrical ratios, they don't have any dimensions. Moreover, they are constant. So, with this we have done, children, and next class we will start uses of dimensional analysis. Okay, see you. Bye bye. Thanks for listening patiently.